transformations on quadratics and on lines. We talked about how do you move the equation up the axis or down the y-axis, or how do we move it right or left, or how do we make it wider. So you've been here for this portion of it, but nobody has been here for a lot of it because we haven't done it. Everybody got one? Okay, on that parent function lab, on the first page, number 1. Okay, on number 1, you've got on every part of this, we're going to talk about different transformations, whether we're moving it up, or moving it down, or right, or left, or whether we are making it wider, or more narrow, different kinds of things. So you need to have your calculator out, like I said a little while ago. Make sure it's turned on, make sure it's cleared out. So you don't have anything else graphed in there, because we're going to be putting things in. And on 1 and 2, we're dealing with 2 types of graphs. 3 and 4 are different types of graphs. 5, 6, 7, 8, and then 9. So we're going to do different things to each pair of graphs that we've got there. So the first one we're going to start off is on 1 and 2. And we're going to answer the questions on each part of it. So number 1, it says in the directions, examine the changes when these parent functions create transformed children. So we've got the parent function. Oh. Alright, so we've got the parent functions, and the first one looks like this. So what's the parent name for that? Linear. It's right there on the board. Linear. So the parent name you should be writing down is linear. What's the equation? So x equals x. That's just the Joey set up. That is the standard parent equation for a linear equation. We talked about that one, I don't know how long. Too long. Alright, so you gotta know the name, you gotta know the equation. Now the next part, it says, okay, the children of this parent are going to have an x plus 3 added and an x minus 3 added. So within that x, we're going to have a plus 3 and a minus 3. And they want to know, what is that equation going to look like? So this one is really simple. It's a little bit more complicated when you get, actually all the other ones in there. It's a little bit more complicated. But when the difference here is because it's in parentheses. So that equation is just going to look like x plus 3 or x minus 3. We're going to have parentheses around it. Do we have to put those parentheses when we graph it, though? No, we don't have to put those when we graph it. So what we're going to do, any idea what that plus 3 or minus 3 is going to do to it? Move it up or down? Okay. So we're going to go to our y equals. We're always going to put our parent function in the y1. So y1 is going to be x. You're putting that in your calculator right now. And then we're going to put in x plus 3 and y2. And x minus 3 and y3. We've got the 3 things in there. Parent function is always going to be the first one. Mine's going to be graphed in color, so the blue will always be the parent function. We're going to make sure we're on a standard window, so zoom 6. Just make sure everybody's looks the same. So this is what yours should look like. Something like that. So let's just sketch in. So this blue one was our parent function, f of x equals x, goes to that 0, 0. The red is the x plus 3. And then it's more like an olive green color. That's the x minus 3. So on that graph, we had, go back. Let's see, it's red. Well, try to keep it with the same color that's on the calculator. So the blue was the parent function, and then the red one the next one, and I guess I'll just have to use gray or something. Now where's the x minus 3? So that one goes there. The f of x is our parent. Ah. Yeah. And then the red's that one. Did it go up 3, right 3, left 3, down 3? What did it do? This is our parent function. This blue line, what did that red line do? It went left 3, but it also went up 3, didn't it? And what did the black or green or whatever you want to call it, what did that line do? It went down 3, but it also went right 3. Okay? Now, I started out with this one because it's a little different than all the other ones, because there's a huge difference whether you put the parentheses in there on all the other ones than if you don't. So the linear one, it does not matter if you think about plus 3, you can think about this, and this is what you're going to write. Well, we'll do that in a minute. Let me just move on down to the next one. That way we can, it'll make a little bit more sense when we do that one. So what is, this is the second one that we're doing the same thing to. What is that parent function? The quadratic. What's the equation? F of x equals x squared. So you got to write both of those down on there. So you got the quadratic, and the parent function was f of x equals x squared. So two things. You should have that filled in on your paper. Those are two easy things. All right, now they're asking us to do the same thing. So the first child, they said, okay, we're still doing the f of x plus 3, but here's where it comes in. We're plugging this x plus 3 where that x is, but that x has a square on it. So it's very important that it looks like that with the parentheses. If you put x squared plus 3, without those parentheses, it's a totally different graph. And on the same thing, when we do the other one, the second child, the x minus 3, is also going to be in parentheses. You should have those two equations down there. You should have the f of x plus 3, the parentheses with a square on it, same thing on the x minus. Go ahead and type those in your calculator. Then you got the parent function in. Then you got your parentheses in. You should be doing this right along with everybody else. Then you got those in your calculator. While 1, while 2, while 3. Standard window again. So your blue is the parent function. We already know what it looks like. The red is the x plus 3, and the gray is the x minus 3. Everybody get that? You need to have those three graphs on your paper. Perfect, just sketch them out. So you got your three different graphs there. Now this time, what did the plus 3 do to it? It moved it which way? It moved it left. You need to start learning the vocabulary for this. That is called, when it goes left or right, a horizontal shift. So this is a horizontal shift left, how much? 3 units. The gray one is a horizontal shift right, 3 units. Now, look at the equations though. Would you not think that plus would move it to the right and minus would move it to the left? What you need to be aware of and what you need to remember, anytime you've got something like this that you're manipulating inside those parentheses, it's the opposite of what you think. We've discussed this before, specifically when we were doing quadratics. So if it's inside the parentheses and it's a plus, that means it's going to go left. If it's outside the parentheses or inside the parentheses and it's a minus, it's going to go to the right. Just the opposite of what you think. Same thing on this one, back up on the linear, when you go plus 3, it's moving it left 3, minus 3, it's moving it right 3. This one's a little tricky because it also goes up and down too. That's why a little bit harder to distinguish. Now, below both of those, they've got a little box there, and it says, describe what happens when x is replaced with x plus 3 when, or not 3, c I mean, sorry. X plus c, and c is greater than 0, and then it says, alright, x is replaced with x minus c, and c is less than 0. So you gotta learn how to generalize, because this is the type of question they're going to give you on ESC. You gotta know how to generalize it. You've already told me that if I put it in parentheses and it's plus 3, I go left. So if I put it in parentheses, no matter what this number is, what is any number that's greater than 0? What can I say about any number greater than 0? What do they all have in common? They're all positive. All these numbers are positive. What can I say about any number less than 0? They're all negative, okay? So if they're all positive and they're all negative, then I can say what's going to happen to this graph. No matter what that number is, I know it's going to be a horizontal shift C units to the right. I'm sorry, not to the right, to the left, because it's a plus. So no matter what, it's going C units. This is like we're placing this number in there for C. It's going to be C units to the left. Same thing for this one. It's going to be a horizontal shift. C units to the right. So you should have that whole top half of that worksheet or that paper filled in right now. So we know how to move an equation, how to move a graph, right or left. When we move it right or left, we're going to add things inside those parentheses. Billy, you don't need to write any of this down? You don't need to write any of this down? Now the bottom two, you've got an absolute value on the first one. You can go ahead and start filling that in, the parent name, the parent equation. While you're waiting, you put the parent name and the parent equation. You can fill in the other side, that parent name and parent equation while you're waiting. Remember, you put those in your notes. for the first one was the absolute value. And what is its parent equation? F of x equals the absolute value symbol of x. This one down here, what kind of parent name is it? It's cubic. Cubic, and what is it? Parent function. F of x equals x cubed. Okay, so we got those two parts. We got two parts on each one of them. Now this time we're doing 2x and 1/2 x. So our children are going to be f important. Where's that 2? What's on the good side? So we're doing f to the 2x on both of them, and f to the 1/2 x. So it's both in the parentheses. So what is this first equation going to look like? Where's that 2 going to be? Inside the absolute value or outside? Is it inside the parentheses or outside? Inside. So that means it should also be inside here. So absolute value of 2x. Same thing down here. What should this one be? Well, that's the value we're doing. I'll skip down to the next one. What should this equation be? Does the 2 also get cubed? Yes, but the 2's inside that parentheses, right? So this is what you're doing. 2x to the 3rd. So it's very different than that. Those two things are very consistent. Okay, those two equations are very different. This is the one you want. This is not the one that you want. So the 1/2, same thing. 1/2 is in the absolute value bars. And it's also being cubed. You got those two equations. Big difference whether that 2 or that 1/2 is inside the absolute value or outside. Or whether it's being cubed or not. So let's go to this absolute value one first. Now, on your calculator, you may remember where absolute value is? You may remember where it is? Okay, you're going to go to math. You're going to go over to number. It's going to be number 1, ABS. Neither may say ABS instead of having the absolute value bars in it. You're not just say ABS. So we're going to have absolute value of x. Then we're going to do the absolute value for math number 1 of 2x. And the absolute value. Now this one's tricky. I got to put in a 1/2. What does that mean? Anytime I put in fractions in the calculator, what do I have to have? Do what? Somebody said it about the parentheses. You gotta have parentheses around that fraction. I don't know who said it. Somebody said it. So 1 divided by 2's got to be in parentheses. Then put your x in there. So you've got those 3 equations in there. Now again, yours may say ABS instead of the absolute value bars. But no, not a big deal. Same thing. So again, blue is the parent function. So there's our absolute value, looks like the x. There's the 2x, and then the 1/2 x. What did that 2 and 1/2 do to it? This one was the 2x, the red one. What did it do from the original? It made it narrower. It stretched it. Think about a rubber band. You got a rubber band, and then I pull it on both ends, it becomes more narrow, right? It stretches it. Right? What did the 1/2 do to it? Like sat down on it, like compressed it, kind of. Okay, so this one made it narrower or stretched it. This one, kinda like you're sitting down on it, made it wider and compressed it. So they call this a stretch and this a compression. Think about like if you're sitting on something and you're compressing it to be smaller. Okay? So, let's see, go back to here and draw this out. Again, it doesn't have to be perfect, but I want the general idea that it's a V and it goes through that point 0, 0. So the other part, it doesn't have to be a perfect graph. I just want you to know it looks like a V. It's more narrow, or narrower than the parent function. And then the 1/2, again, doesn't have to be perfect. I just want to know that it looks like a V and it goes through that 0, 0 point. Because we've not moved it right or left. We've not added or subtracted or moved it up or down or anything. All we've done is made it more narrow, we stretched it, we compressed it, and made it flatter. If you want to use that one. So by knowing that, what should this one also do? What should that 2 do to this parent function? Does 2 stretch it? What should the 1/2 do to it? Compress it. So I'm about to just let y'all do the rest of this yourself because I got half of you doing nothing. And I've got the other half of you, a quarter of you, sitting there waiting for me to write the answers up here. Alright, so if you're going to put in the x cubed, there's 2 ways you can do it. You can do x to the 3rd. You can do x to the 3rd, or you can say x and go to math, and then number 3 is also to the 3rd power. Either way you want to do it. Same thing. You can go x and use the caret button, the to the button, and put your exponent up there, or you can go to the math function. So you've got your x to the 3rd. You've got to be careful. These have to be in parentheses. So you want the calculator to know not only am I cubing the x, I'm also cubing the 2. And then you got to be really careful on that 1/2. You've got to tell the calculator, I want you to cube all this, but then what do we have to have for the fraction? We got another set of parentheses where we say 1 divided by 2, and we close that. We've got our fraction in parentheses, but then we've got this parentheses that's outside it, and we have to close that one and put to the 3rd on it. Sounds a little tricky. You got to put the fraction in parentheses anyway. But then you got to tell the calculator, hey, I want all of it to be cubed, not just the edge, not just the 1/2. I need all of it to be cubed. So we're expecting it, like I said, some of you, to stretch it. So there's the 2x cubed, and to compress it like that. Go ahead and draw your little sketch there. Again, doesn't have to be perfect. You just want to know that everything. You're getting this error because you're not putting the beginning parentheses right here. You gotta have the parentheses just like this one, where we had a parentheses around the whole thing, and you have to have another set of parentheses around the 1/2. So draw your little sketches there. Again, doesn't have to be perfect. So that 2x to the 3rd, as long as it goes through that 0, 0, and then your 1/2. As long as it's like a general idea, and then it goes through that 0, 0, you're good. So we've moved it right and left. We stretched it and we compressed it. we've gotta fill in that box at the bottom though. We've gotta generalize it. This time I think they have an A instead of a C. Yeah. Says, all right, what happens when X is replaced with AX, but A is greater than 1? That's the 2. What happened to it? When A is greater than 1, when this number is greater than 1, when we multiply it by something greater than 1, what happens to our graph? What happened to the red graph? What's the vocabulary we just used? Not compressed means it was flattened. Rubber band. Stretched. It was stretched. How many units? 8. You've got to generalize it. You can't say a number. You're trying to generalize for everything. So it stretches the graph A units. Whatever A is. We don't know what it is. But no matter what that number is, it's going to stretch it by that number, by that factor. Now the one below that says, okay, we're replacing X with AX, but this time they've got 0 is less than A is less than 1. Really what that means is A is a fraction, or A is a decimal between 0 and 1. Doesn't say anything about being negative. It's a big misconception. People think if it's negative, it makes it smaller, but it doesn't. So what happened to the 1/2? We put 1/2 on here. What happened to the gray graph? Use the vocabulary we need. It compressed it A unit. So it compresses the graph A unit. Right, so we've moved it right or left, and we can see. We've moved it, or we've not moved it. We've stretched it and compressed it using A. Now the one on the back there, you're waiting for everyone else to copy this. Go ahead and look at the one on the back and see if you can figure out what that one does. Go ahead and write in the parent name and the parent equation. Those are simple. Up on the board. If you finish writing all that on that screen there, go ahead and go to the next one and see what you get. Actually looking them up makes a big difference in how you learn it. Looking at the board, writing them down, is another way you can learn it. Everybody's got that one. See how much you can fill in while I'm drawing these graphs. I'm just writing down what you wrote in little boxes. square root of x. That's simple enough. All right, what's this one? The reciprocal. Okay, so this is the reciprocal. And it is 1 over x. This is also called an inverse variation, which we'll learn in math too. But for now, we're just going to call it a reciprocal. Alright, so what are we doing to the children this time? What is the difference between this and what we did on 1 and 2? Not just that the numbers are 2 and the numbers are 3. What is the difference between 5 and 6, what we're doing to the children on 5 and 6, and what we're doing to the children on 1 and 2? What's that difference? Well, we got one's a plus and one's a minus. They got different numbers, but that's not what I'm looking for. That's not the main difference. Say it louder for me, Timothy. The plus and the minus are outside the parentheses. And I should have wrote those in the colors. Notice, where were these pluses and minus? Inside the parentheses. This time, they're outside the parentheses. So this one in red, I'm going to have the square root of x, but then I'm going to have a plus 2 outside the square root. It's not going to be inside the square root, it's outside the square root. So the same thing on the minus. This one would be the square root of x minus 2. So then we could go ahead and tell them this one is a little bit different. Outside the parentheses, so this one would be, let's see, red. Anybody want an idea? 1 over x plus 2, and this one would be 1 over x minus 2. Okay, so we know if we do something inside the parentheses, it moves it right or left. If we multiply by something, it stretches or compresses. So now we're adding and subtracting outside of the parentheses. Yes, sir? Okay, I got one goes right, one goes left. Anybody else? Now you're going to up or down? Okay, so another guess, up or down. Anybody else? Do what? Right or left, side to side. Alright, so we got to be careful when we put these in the calculator. So let's go back, make sure you clear everything out. Alright, so you've got 1 divided by x. There's your parent function. Your reciprocal. If I just hit graph, you can see that one. It'll draw the graph. It looks like it touches these axes. It never touches it. You get closer and closer and closer, but it never touches the axis. Okay? Same thing on this side. Looks like it touches it, but it never does. It'll get closer and closer and closer and closer and closer and closer and closer. It'll never touch it. Okay? Now, when we put in that next one, we're going to say 1 divided by x. 1 divided by x. Now, I want that plus 2 out by itself. Will that work, or do I need to put 1 divided by x in parentheses and then do plus 2? It might make sense to do parentheses, but in this case it doesn't matter. But like I said, we've got a fraction, and I've always said if you've got fractions, put them in parentheses. So just as a precautionary measure, you might want to do that, but it's not going to matter. I'll do this next one without parentheses, and you'll see 1 divided by x minus 2. Now, it would make a huge difference if we wanted to move it a certain way. So, we got our parent function in blue, the plus 2 in red, and the minus 2 in the gray. So which way did it move it? Up and down. But this time, the plus 2, the red, moved it the way you would think it would move it. It moved it up, didn't it? The minus 2 moved it down. Okay, so that one's pretty simple. So let's draw our graph there. Did I mess y'all up because I started with the bottom one? water if you wanna actually look at somebody's name. See, that's a general graph there. The square root's gonna be the same way, so we should be able to draw that graph with an idea of what it looks like without graphing it and just check. So given that that other one moved it up 2 and down 2, wouldn't it make sense that the other one got moved up 2 and down 2 if we just checked it? So if we go in and put square root, you got the parent function, the square root of x. Now this one you gotta be careful. If I do the square root of x, and I just go ahead and hit plus 2, why is that incorrect? The plus 2 is inside the square root of it. So you gotta be careful on this one. So if I come back, I'm gonna put the square root of x, and then I'm gonna use my right arrow to get out of that square root. It's a huge difference. So now that's plus 2. We do the same thing with the bottom one on minus 2. You got the square root of x plus 2 and square root of x minus 2. And then hit graph, and you'll see that it'll move it up and then down 2. And the general sketch, and you're good with that one. So that generalization at the bottom, they've got, let's see, when C is added to the f of x, meaning it's on the outside of it, or you could think of it like this, f of x plus c, or f of x minus c is outside of the parentheses, what happens to it? This is giving me a generalization statement. Graph C. Do what? It goes up or down, but we gotta use the vocabulary that we kinda used before when we had a horizontal shift. This is not a horizontal shift, what is it? It's a vertical shift. So this is a vertical shift of what? Of C units. And then the minus would be a what? Vertical shift down 2 units. Okay. I already got that written down. Go ahead and you can write those next to put the parent function name in the equation. Parent function name, parent function equation. Number 7, we've already done that kind of parent equation. What is it? It's a quadratic. So f of x equals x squared. Number 8, have we done 8? Yeah, it's already a cubic. What's the difference between 7 and 8 and 4? What's the difference on the children? What's the difference between 7 and 8 and 4? On number 4, the 1/2 and the 2 are in the parentheses, and on 7 and 8, it's outside. So we know that when we did number 4, or 3 and 4, we know when it was inside, it stretched it or it what? Move it side to side. Anybody else? That must be really boring to actually like have a conversation with. Because you just did it. Nobody can guess. Nobody can make any kind of guess whatsoever. Besides Michaela. Here's a little word of help. Don't get a job where you actually have to be creative or think outside the box. Because you've got to actually step up and say something. Right or wrong, you've got to be willing to put yourself out there. So don't try to go get a job where you've got to create something. If you just sit there and do nothing, you're not going to do very good at your job. You're going to make mistakes, so you got to try something. So Michaela, what was it you said? Okay. All right, so before we did on number 3, here. Okay, so number 3 we had the x squared, and we put a a 2x squared on it, just to refresh your memory. So we have the x squared, and we put a 2x squared on it, but we put the 2 inside the parentheses. This time we're putting the 2 outside the parentheses, so we're doing 2x squared, so the square is only on the x, not on the 2. So how does it change it? Did it change it? It's from the blue. Did that black one change any from the blue? It changed it a little, but look at the equations, guys. If the original equation was this, f of x equals x squared, we did this one first. We put the 2 inside, and we just did this one where the 2's on the outside. If I could simplify that right there, what would that simplify to? What's 2 squared? 4. So this is really 4x squared. Those two things are the exact same thing. So are we kind of doing the same thing, but this one has a bigger number than this one? Yeah, so if I'm back on my calculator, and instead of writing it like this, I just put 4x squared there. Is it going to give me the exact same thing that I had a minute ago? Is the exact same thing? Yeah. So that 2 inside those parentheses didn't change anything, did it? Whether we put it inside or outside. So what do you think the 1/2 is going to do? Whether I put the 1/2 inside or outside. Before, we put the 1 divided by 2 in parentheses, and then put the x with a square on it. We got that. We have the original parent function, and then we did the 1/2, which means we compressed it. But if I pull that 1/2 out, what do you think it's going to do to it? So now the only thing that's being squared is the x, not the 1/2. Just the x. What's it going to look like? Is it going to be flatter than the red one? Or in between them? Flatter than the red one? Okay. And so it's in between. Same thing that we just did a minute ago. It's just not as, on here, if I square 1/2, square 1/2, well, 1 squared is 1, 2 squared is 4. So it's the same thing. It's not a big of drastic difference there. I don't want to worry about number 4 because it's the same thing. Or not number 4, number 8. What I do want to do is go to number 9. Look at 9. First of all, what's that parent name? cube root. So go ahead and write that in there. You got cube root. And go ahead and write the equation. So it's the opposite of the cubic. Kind of like taking the cubic one and turning it on its edge. But now, let's see, so we've got cube root. And we've got f of x equals cube root of x. But then they've got two children. Where the first one, they've got a negative outside the cube root. So we would have a negative cube root of x. And the other one, we've got a negative inside it. So it's cube root of negative x. And we've got negatives underneath it, whether it's inside or outside. And we'll talk about ones like these before on a negative. Think about on a linear, on a slope. What the difference between a positive slope and a negative slope is. Any guesses what the negative's going to do to it? Move it up. Anybody got anything else different? Move it down. Anybody else? Alright, now the cube root. Now your cube root, go to math, right there, number 4. You got the cube root of x, you got the negative cube root of x. Put that in there. And then you've got the cube root of x, and you've got the negative x. So now 4 of them in there. Okay. What I've done, I've turned this one off, so I'm not graphing it yet. All you're going to do is see 2 of them. So you're going to see the parent and the one with the negatives on the outside. So there's the parent. There's the negative on the outside. So what did it do to it? It flipped it. This part got flipped up here. This part got flipped down here, so it flipped it. So now, any guesses on whether I put that negative on the inside, what it's going to do to it? Turn it back the other way? Should be. Anybody else? Nobody else? Alright, let me go back in here. I'm going to turn this one off and turn this one on. So now we're going to get the parent and the one with the negatives on the inside. So it's great.
I need to track athletes who ordered pant cloth to report to the coach's office to pick up those materials. Thank you.
Where's the gray one? What'd you say?
I meant like, they want to go,
Is it there?
no,
It is.
I
It's the same one. It did flip it back over. It did flip it back over. It's just graphed on here and you can't see it. And it's there. Okay?
I'd like to, but I was going to be, it was dreadful.
What it was gonna do what, Marcus?
There's never a question whether it's good.
No, there's not. It would be better if they did like maybe a dotted line on here, so you could see it, but no. Okay, so down there, what happens when, look at how they said it. F of x is negated, and f of x, when x is negated. Kind of a funny way to put it, isn't it? But what did it do? It flipped it. So I put it, it just flipped it. Alright, so as long as you got it, flipped it down here. Or it was a mirror image across the x-axis, you could put that. Either way. Okay, now. We have this is your actual homework, but you should use all of those things that you did. equations in the first one. Now turn up an area. Alright, so the first one says f of x equals x plus 6. This is the one like the very first one we did. So the first column has the equation. Second column says the equation of the parent function. And what's the parent function then? Take off all the numbers, what's the parent function? F of x equals x. So that's what you're going to put right here. F of x equals x. We'll go linear. Okay, so that's your first one. Then the next, last column says, all right, what was the transformation? Okay, go back to number 1, and what did we say there? Go back to number 1, and what did we say there? Some horizontal shift of how much? We're not generalization, we're not generalizing. 6 to the, look at the paper, what did we say? We say horizontal shift 6 units to the left. So you're going to write horizontal shift 6 units to the left. Horizontal shift 6 units to the left. Okay. I've just done the first one for you. For those of you not doing it, you're lazy. I'm sorry. You're doing nothing. Tired of sugarcoating things. Okay, so here's the next one. 2 numbers, that means there's 2 things that have done to it. Take all the numbers off, and what parent function do we have? F of x equals x squared, the quadratic. F of x equals x squared. Alright, so there's 2 things, I'll tell you, there's 2 things. Here's one number, here's one number. They both do different things to it. Go to your quadratic on number 3, I believe. Not sure, maybe it was something else. Maybe we did the quadratic on the 7, not 3. On 7, what does that number right there do to it? What does that number 5 do to it? What did the 2 do to it? What did the 1/2 do to it? It stretches it 5 units. So you're going to put stretches. Yep. 5. Anyway, so it stretches at 5 units. So while this goes on, what does that minus 1 do to it? Now, have we done anything, do you see anything on that paper we just spent the last 45 minutes on where we added or subtracted and we said it stretched or compressed it? No. Find the section where we added or subtracted something outside the parentheses. And what did we do? I didn't just spend the last 45 minutes of my life just talking, because I wanted to hear myself talk.
Simple number vertical on the y.
Okay, so how do we say that? You're right. Not a horizontal shift,
Vertical shift.
a vertical shift, 1 unit down. Vertical shift, 1 unit down. So the second part is a vertical shift, 1 unit down. Alright, the next one says negative x squared. F of x equals negative x squared. Thank you, lady. F of x equals negative x squared. So take away all the numbers, all the negatives, whatever. What is that parent function? It's not the parent function, but that's because it's going to occur. What do you say, Linda? I can't hear you. F of x equals x squared. Take away all the negatives and positives and the numbers and the signs. What do you have left? X squared. F of x equals x squared. What does that negative do to it? The last one we just did on that paper. What did we do at the very bottom on number 9? It flipped it.